So we're going to pick up on sample exercise 20, and we're going to look at the pH of an aluminum chloride solution. And notice they give you a Ka value for not aluminum chloride. They give you a Ka value for this weird-looking complex. By the way, that's called a complex ion. Okay, if it looks complicated, it is truly a complex ion. I know, it is. It's kind of funny. Right. Okay, so the information that they're giving us actually is telling us which part to worry about. But what if we didn't have that information? Then we need to look at each piece of our salt and think it through. AlOH, if I put that OH on the end of that, is that one of your strong species? It's Al, aluminum hydroxide. No, so that comes from a weak base. How about Cl? If you put an H on the front of that, that comes from a strong acid. So that little cheater method of showing you which one is going to win, strong always wins, this is going to be an acidic solution. So your pH is going to be lower than 7, okay? Kind of a way of checking yourself, did I do this right? And so that means that it's not about the strong one anymore, okay? Once you decide that, then it's all about the weak species and how it interacts with water. So aluminum plus HOH is going to, it looks like, make that complex thing in water, but it's still going to rip water apart, okay? So you end up with one of these hydrogens coming off of this, and I'm not seeing that.
It's acidic.
It's coming from a weak base, so you're right, it's acidic. My bad. So how are we gonna, what's going on? It's complexing. We know this is gonna happen. This is gonna happen, 6, 3 plus, so my bad. Let's get rid of that. It complexes with water when you put that aluminum ion in there. So they went ahead and told you this is what species you're forming. You're forming this, okay? And then
why did we make mine is aluminum, whatever, aluminum water. Mine said 3 plus. Why didn't you lose the hydrogen? Because you go to water.
yeah, I know, I am too. I'm sorry. Okay.
One of the hydrogens was water, right?
Uh-huh.
H2O.
Uh-huh.
The aluminum H2O6 3 plus didn't lose one.
Right. And we have a Ka value for this, but exactly. So let me do something here. All right. So if we have this, if this acts as an acid, H2O, 6 positive, 6 and 3, and you put this in water, okay, because they're saying this is the Ka value for this, right? Okay. So let's just get rid of this other equation. I'm going to just get rid of that. Okay, so if this is acting as an acid, it has to donate one of the hydrogens from from one of the waters in here. Okay, and so when it donates that, we know we come up with hydronium, plus we come up with Al H2O, but one of those waters broke apart, 5, and then we have the OH minus attached to it. But the charge is going to be a +2. Thank you. Good job, guys. Okay, but here's the question. Okay, Jamari. That's an equation for this species at this point. That's the equation for that. The OH is actually attached to this complex ion. Yeah.
You only lost hydrogen.
HOH is just another way of writing H2O.
It's the same thing.
It's the same thing. Why are we putting an OH? Okay, so look at what happened between here and here. Okay, so we reduced the number of waters, right? Okay, so one of these water molecules that's embedded in this complex ion actually gets split apart. So that's where the OH comes from. It's just one of these waters in that species is getting broken up. Where does the H go? It goes to the water to form the hydronium. And then you're left with an OH, right? Okay, and so that's where it just attaches to that complex. Does that make a little bit more sense on that part? Okay. Now, whew, yeah, I'm with you. And I'm going to tell you that they'll give you that equation. Okay. So the equation would be given to you. You weren't going to have to. Yeah. Don't spend that much time crying about it. Just, because honestly, it's going to be given to you. Now, the question that I'm thinking through here is we actually didn't have this complex. We only had aluminum. So whenever aluminum buddies up with water, it forms this thing, okay? And so when it forms this thing, once it makes some more water, meets up with some more water, then it does actually form this. So we've got like two processes that are happening, okay? You've got the aluminum ion that's going to be dumped off into water. Whenever it meets up with 6 water molecules, it will form this complex ion. So this complex ion is going to act as an acid. So it's like a 2-step process here, okay? So the equation that we have written now is the acidic equation that we needed. And they gave us a Ka value for this one. They were really nice in that. So we're not having to look for Kb or anything like that. We're looking for this. We already decided this was going to act as an acidic reaction. Okay, and we have a Ka for that. Are we cool with that part? Okay, so now what are we going to do? Find the pH. Okay, so that's pretty straightforward, isn't it? We can just do Ka, is 1.4 times 10 to the negative 5th. And then what are we going to put on top? If y'all want to write all that out, you're more than welcome to, but I'm just going to because I'm running out of room on my paper, I'm going to put x squared, okay? And then on the bottom, we're going to put 0.01, 0. And when we solve for our x, that's going to be our H3O plus, and then we can take the negative log of that, and that's going to give us our pH. So I was almost right in the first equation that I marked out up there, except my thought process was not going in the right direction. I was trying to do something with that. And all that happens is the aluminum forms that complex ion first, and then it keeps acting with water. Okay.
I got 3.43 is the pH.
All right. Now, the math part was way easier than the trying to come up with that crazy equation. Yeah. So the great thing about this, though, guys, is like on the AP type problems, they'll give you that equation. Okay. Yeah. Yeah. It'll make it way easier. Okay. So let's talk about acid-base properties. We've actually kind of already jumped headlong into acid-base properties of salts. So I feel like this should have been a prior question. It wasn't. Let's decide if these are acidic, basic, or neutral, except, oh my goodness, you know what they did? They gave us, most of these are actually coming from a weak species. So we have to decide who's going to win by looking at a table. Okay? All right. So we have NH4. What is that the conjugate of? NH3. So that comes from a weak base. And we have acetic, or the acetate ion, which comes from acetic acid, and that is a weak acid. Oh my goodness. Guess what? This one will actually be neutral, but only for this reason. The Kb of NH4 happens to be 1.8 times 10 to the negative 5th. The Ka for At the acetic acid happens to be 1.8 times 10 to the negative fifth. So you guys are right in that we come up with a neutral solution. Okay, that is us. We didn't get very far, but that's okay. All right, so let me see your paper real quick. Let me see what I want you to. So guys, your job or homework, well, I think honestly you can do these. I think you can do them. Do the front side though, okay? Just do the front. Hey, I did not have a chance to get that done. Okay, I will have a chance this next period to get it done, I think. Okay? Thank you.